Okay. Today, I want to talk about the two sections, section 11.8 and the 11.9. The first one, 11.8, the power series. This is like outline. I want to talk about the definition of a power series. The second one, how can we check whether a power series converges or diverges? The third one, I want to talk about the definition of radius of convergence and interval of convergence. I talk about three kind of things today. The first one, was like a power series. The power series is summation from n equal to 0 to infinity, Cn times x to the n. The expanded form is C0 plus C1x plus C2x squared plus C3x cubed plus and so on. Where x is a variable, the Cn is a constant, called the coefficients of the series. What's the domain of F? The domain of power series is the set of all x values for which the series converges. This example, find the domain of f of x. The f of x is summation from n equal to 0 to infinity, x to the power n. You plug n equal to 0, n equal to 1, n equal to 2 into the n. We have 1 plus x squared plus x cubed plus x to the 4 plus and so on. This is like a power series. So how can you find? So I want to use geometric series. Can you remind this previous one? Summation from n equal to 1 to infinity, a times r to the n minus 1 equals a plus ar plus ar squared plus ar cubed and so on. We have two results depending on absolute value of common ratio r. The absolute value of common ratio is less than 1. Geometric series is convergent. The absolute value of common ratio is greater than or equal to 1. The geometric series is divergent. We have two kind of results depending on. So from this one, here, this is like a geometric series because how can you find the x from the 1? The 1 times x is x. How can you find the x squared from x? X times x is x squared. How can you find the x cubed from the x squared? X squared times x, x of 4, same idea, times x, like this. So what's the common ratio r? What's the common ratio r? In this problem, what's the common ratio? Yes, like x. This is common ratio. The ratio r. So when do you have a conversion result? So common ratio, absolute value common ratio is less than 1. So we can think about like this one. This absolute value of common ratio is less than 1. I want to solve this inequality. X is between minus 1 and 1, like this. So we have this result. Power series n equal to 0 to infinity, xn converges if x is between minus 1 and 1. So what's the domain? The domain is open interval minus 1 and 1. That's it. This is the whole idea for solving this kind of problem. So like this. Yep. The next one. More generally, a series of the form summation from n equal to 0 to infinity, Cn times x minus a to the power n. The expanded form is C0 plus C1 times x minus a plus C2 times x minus a square plus C3 x minus a cube and so on is called a power series in x minus a, or a power series centered at a, or a power series about a. We call it like this, like a power series, like a general form. The remark, x equals a, the what happens? The here, you can plug a into, here you plug this x value into, here plug into a into x, so change it, this is a, this is a, this is a. What's expanded form? So like this. So what happens? This is going to 0. This is 0. This is 0. The remaining term is only C0. So what happens? Power series is finite number. The power series is finite number. So what does it mean? The power series is always convergent at A. Is right? It's the exact meaning. Series is a finite number. So what does it mean? Series is convergent. So this is one important result. The power series is always convergent at A. A is the center of the series. The next one. For what values of x is the series? Summation n equal to 0 to infinity n factorial x to the n. So let me see. If you want to solve this problem, you have to check the power series summation from n equal to 0 to infinity n factorial x to the n is convergent or divergent. You have to check these kind of things. So how can you check this series is convergent or divergent? We have 7 tests, remember? So test for divergence, the integral test, the direct comparison test, limit comparison test, alternating series test, ratio test, and the root test. Which test is possible for checking the series is convergent or divergent? So Kevin said ratio test. So what do you think? Is right? The ratio test is possible? The Odari said ratio test. So what do you think? Is right? So yeah, the ratio test. Okay, it's right. The series involves factorial forms or other products, including a constant raised to the nth power, c to the power n, c to the power 2n, c to the power n squared. So we always use ratio test. So what's the ratio test? The limit of absolute value of an plus 1 over an. So how can you solve? So this is same to limit n approaching infinity. So what's the an plus 1? You plug n plus 1 into this n. So we have absolute value of n plus 1 factorial x to the power n plus 1 over an is n factorial times x to the n. So like this. This is same to limit n approaching infinity. I can change it n plus 1 factorial to n plus 1 times n factorial, the same. What's x to the n plus 1? You can just split x to the n times x to the power 1 over n factorial x to the n, so like this. So what happens? N factorial is crossed out. X to the n is crossed out. It's the same to limit. N approaches infinity, absolute value of n plus 1 times x. So like this. So what's the next one? this n plus 1 is always positive number. You can take out positive 1. This is a limit n approach infinity. N plus 1 times absolute value of x. So we have it. What is limit? What's the limit? Infinity? Is right? Infinity? Infinity? Yup. Infinity? Yup. We have two answers. So if x is not equal to 0, the non-zero number times infinity is infinity. It's good. Another one, x equal to 0. X is what? 0. What's 0 times n plus 1? 0 times n plus 1 is 0. The limit of 0 is 0. We have two answers. So what's that? Infinity is greater than 1. Series is divergent. 0 is less than 1. This is convergent. What's like conclusion? The series summation n equal to 0 to infinity n factorial times x to the n is convergent. So when at x equal to only 1.0, this is like a whole idea for solving this problem. This is a lecture, so like this. It's good. Second one, for what value of x does the series converges? So what kind of method, what kind of test do you want to use for checking this series is convergent or divergent? So what kind of test do you want to use? The test for divergence, direct comparison, the Kevin said the ratio test, O'Dowd said the ratio test. Is right? Exactly ratio test? Yeah, the same reason. We have c to the n. This is like x minus 3 is like this whole thing is what? C to the n form. You can use ratio test. Ratio test. So what's that? You can just split limit n approach infinity absolute value of an plus 1 times 1 of n. So this is the same to limit n approaches infinity. What's an plus 1? You plug n plus 1 into this n. This n. So we have absolute value of x minus 3 to the power n plus 1 over n plus 1 is exactly a sub 10 plus 1 times 1 over an. What's 1 over n? The reciprocal of an. So we have n over x minus 3 to the power n. So like this. So what's the next step? This is the same to limit n approach infinity absolute value of x minus 3 to the power n times x minus 3 is like first numerator over n plus 1 times n over x minus 3 to the power n. So what happens? X minus 3 to the n is crossed out. The remaining thing is limit n approach infinity absolute value of x minus 3 times n over n plus 1. The same. This n is positive number, n plus 1 is positive number. You have to take out limit n approach infinity. We have n over n plus 1 times absolute value of x minus 3, or like this. Next, you can calculate the n over n plus 1. The 1 is like coefficient, This is not coefficient. This is constant. You have to ignore constant. You have to cross out n. Answer is the absolute value of x minus 3. So when do you have a conversion result? This limit value is less than 1 converge. Right? This is like idea. You can use it here, like this. Yeah, x minus 3 is less than 1 conversion, the greater than 1 diversion. So we have this result. Next, you have to solve this inequality for conversion result. So here, you can solve. This case is x minus 3 is between minus 1 and 1. You add 3 to both sides. This is same to 3 is cancelled. X is greater than. Minus 1 plus 3 is only 2. 1 plus 3 is like 4. So we have it like this. So we have this result. Series is conversion when x is between 2 and 4. But this is not a final. So let me see. The ratio test is inconclusive when the absolute value of x minus 3 is equal to 1. Remember, the limit value is exactly 1. So this case is inconclusive. So what's it like x value? So satisfying this inequality. This is x is what? 2 and 4 exactly end point. So what does it mean? So you have to check. The power series is conversion or diversion at end points 2 and 4. This is next step. Case x equals to 2. You can plug this value 2 into x. So we have it. The same to summation from n equal to 1 to infinity minus 1 to n 1 over n. The series is conversion or diversion. What do you think? The series is conversion or diversion. This one. This series is conversion or diversion. Conversion. Is it conversion? So what kind of test do you want to use? Yeah, the conditional conversion is like a conversion. The question is not absolute conversion, not conditional conversion, just conversion or diversion. The either is fine. The conditionally conversion or absolutely conversion, the exactly conversion. So alternating series test. It's good. So the series converges by using alternating series test. Do you remember alternating series test? You can remind very quickly what's alternating series. The summation n equal to 1 to infinity. We have alternating series. The like this. The Pn is always positive. The satisfies two conditions. The first condition is sequence Bn is decreasing. The second condition is limit of Bn. The limit of Bn is going to 0. What's the conclusion? Conclusion is alternating series is conversion. So we call alternating series testing. Bn converges. So like this. So I can apply this problem. What's it like Bn? The Bn is 1 over n. You think about first condition. You plug 1 into n. The first term is 1 over 1. Second term is 1 over 2. The third term is 1 over 3. What happens? Yes, decreasing. The second condition, limit of Bn. Limit of n approaching infinity, Bn is 1 over n is going to 0. That satisfies first condition, second condition. The conclusion is summation n equal to 1 to infinity minus 1 to power n 1 over n is conversion by using alternating series testing. This is the idea. Second case, you plug right in the point 4. You plug 4 into x. You plug this value 4 into x. So this one, the 4 minus 3 to the power n is 1 to power n. 1 to power n is exactly 1. So we have summation 1 over n. So this series is convergent or divergent. What do you think? Divergent. The y. Divergent, the y. Why this series is divergent? Yeah, harmonic series or P series, it's good, either one. Yeah, harmonic series or P series, this is divergent. P equals 1, so this series is divergent. Was it like a final answer? Only convergent at x equals 2, only include. X is greater than y equal to 2, less than 4. So this is the idea. Third one. So I want to find the domain. So how can I do that? I want to use ratio test again because we have factorial form. What's an plus 1? This one. So we have limit n approaching infinity, absolute value of an plus 1 times 1 over n. So like this. So this is same to limit n approaching infinity. So what's that? You plug n plus 1 into n. Plug into n. So what's that? Absolute value of minus 1 to power n plus 1. X to the 2 times, you can use parentheses, n plus 1. Over 2 to the 2 times, same, n plus 1. Times n plus 1 factorial squared times, this is 1 over an. The 1 over an. 1 over an is reciprocal. The reciprocal of an. So 2 to the 2n times n factorial square over minus 1 to power n, x to the power 2n. So this is exactly the limit of absolute value of an plus 1 over an. So we have it like this. Next, simplify, is right here. Distribute 2. 2n plus 2 is exactly here. Same, distribute 2. 2n plus 2 is here. What is n plus 1 factorial? N plus 1 factorial is n plus 1 times n factorial. We have here, right? So next, expand. The x to the 2n plus 2 is x to the 2n times x squared. The 2 to the 2n plus 2 is 2 to the 2n times 2 to the n. The next, distribute 2 to the n plus 1 and n factorial. N plus 1 squared, n factorial squared, right? The next step is simplify. You have to cross out x to the 2n, 2 to the 2n, n factorial squared. The remaining part is, numerator is x squared. The 2 squared is 4. n plus 1 squared is here, like this. So what is the answer? What is the limit? What's the limit? What's the limit? X squared over 4 times n plus 1 squared is 1 over 4. Is it right? Is it 1 over 4? So what do you think? 1 over 4? 1 over 4? 0? 0? 0? Answer is 0. So really be careful. The numerator is not n squared. Exactly x squared. So what does it mean? So you can take out coefficient. Only n value approaching infinity, x squared is like constant. This is a constant. So with respect to with respect to n. So take out. You have to take out x squared. The next one, limit of this one is 0. 0 times x squared is 0. The 0 is always less than 1 for all x values. So by the ratio test, series converges for all values of x. That's it. This is idea for solving this problem. The domain is all real numbers. It's good? Here, we have the one theorem. From the first and second and third examples, we have one important theorem. For a given power series, summation from n equal to 0 to infinity, c sub 2n x minus a to the power n, there are only three possibilities. The first possibility is that the series converges only one point x equals a. The series converges for all x values. Third one, there is a positive number r such that the series converges if absolute value of x minus a is less than r, or diverges absolute value of x minus a is greater than r. So this is very important. So we have name of radius of convergence and interval of convergence. Case 1, here. Case 1, this case 1, series converges only when x equal to a. What's the radius of convergence? Radius convergence is 0, only 1.0. The interval of convergence is 1 point a. Second case, here, series converges for all x. Radius convergence is infinity because the length of all real numbers is infinity. Divided by 2 is like infinity. Interval of convergence is minus infinity to infinity. Here, third case, the absolute value of x minus a is less than r. Series is convergent. Was it like a conclusion? R. So this number r is radius of convergence. What's the interval of convergence? We have 4 possibilities because you try to solve this problem. This is the same to x minus a is between negative r and r. You add a to each side. Each side. This is same to x is greater than a minus r less than a plus r. So we have 4 possibilities depending on endpoint. The left-hand point, right-hand point excluded, open interval. Only right-hand point is included. Here, only left-hand point included, half closed interval. The left-hand point, right-hand point included the convergence. This is like a closed interval. We have 4 possible interval of convergence in third case. This is the whole idea. So we are going back to previous one. Here, the first example, summation n equal to 0 to infinity, n factorial x to the power n converges when x equal to 0. What is radius of convergence? What's that? What's the radius convergence? What's that? Radius convergence is, do you know what's the radius convergence of this case? So this is the first example. Series converges when x equal to 0. Do you know? Zero, x equals a. So here, radius convergence is 0. So what does it mean? So what's the point? This is only one point. This is not the same. So this meaning is like the length of point. The length of point is 0. So one more, the divided by 2 is also 0. The radius convergence is 0. The interval of convergence is send notation 0. You can do send notation 0 like this. Right? So I want to give it one more thing. Summation n equal to 0 to infinity, n factorial x minus 5 to the power n converges when x equals 5. So what is radius of convergence? What do you think? What is the radius of convergence of this problem? What's your answer? What's the radius of convergence? 5? 5? 5? No. 0. The y here. 5 is only 1 point. What is length of 0.5? Length is 0. The what's the radius? Divided by 2. 0 over 2 is 0. The radius convergence is 0. What is interval of convergence? What's interval of convergence? Yes, this is 0.5. This is really be careful. The power series converges when only 1 point x equals 5. The radius convergence is 0. Interval of convergence is one number 5. The second one. This is a third example. Third example converges for all values of x. What is radius of convergence of a second case? What is the radius of convergence of a second case? Yes, infinity. All real numbers. All real numbers, infinity. The all real numbers, infinity. What's the interval of convergence? All real numbers, mass infinity to infinity. This is the idea. Third one. Series converges for 2 and 4. Like this. What is radius of convergence? What's the radius convergence? 2, 2, 2, 1, 1. Is it right? This is 1. Because what's like the radius of this is the interval of convergence is here 2 to 4. What is length of 2 to 4? The length is 4 minus 2 equals 2. What's the radius? Divided by 2 is 1. So radius convergence is 1. So like this, 1. What's the interval of convergence? Yeah, half closed interval is the whole thing. The half closed interval 2 and 4. How to find radius of convergence, interval of convergence? So main key is ratio test or root test. This is like a main idea. The ratio test or root test. So this problem, find the radius of convergence and interval of convergence of the series summation from n equal to 0 to infinity, negative 3 to power n, x minus a to the power n over the square root of n plus 1. So you use ratio test. When you do use a ratio test, the constant to the power n or factorial form, we have it. Constant to the power n, the constant to the power n, like this, use a ratio test. The limit, absolute value of an plus 1 over an, like this. What's it like an plus 1? I can do right here. It's the same to what? The limit n approaching infinity, the absolute value of an plus 1 times 1 over an. This is same to limit n approaching infinity, absolute value of an plus 1, you plug n plus 1 into n. So we have negative 3 to the power n plus 1 times x minus 2 to the power n plus 1 over the square root of n plus 1 plus 1 times the 1 over an is reciprocal, square root of n plus 1 over the negative 3 to the power n x minus 2 to the power n. This is exactly an plus 1 over an. So we have it. The next simplify. So this one is exactly same to negative 3 to the n times negative 3. X minus 2 to the n plus 1 is x minus 2 to the power n times x minus 2. n plus 1 plus 1 is n plus 2. You can change it like this. Next, cross out common factor. Common factor. Here, this is same to limit n approach infinity, the absolute value of negative 3 times x minus 2 times square root of n plus 1 over square root of n plus 2. This is like absolute value sign. What does it mean? Change it, positive, it's good. The 3 is a positive number, take out. The root n plus 1 is positive number, take out. The square root of n plus 2 is positive 1, the take out. We have this reserved. The next, so you have to ignore constant term. So like this, we have it. Next, take limit is crossed out. Answer is 3 times absolute value of x minus 2. So when do you have a conversion result, the series is absolute conversion and therefore conversion when the limit value is less than 1. The greater than 1, divergent. So we have this inequality. And solve. Here, you can divide by 3. We have it, divided by 3. Next, eliminate 2. Next, add 2 to each side. Middle one is just x. The minus 1/3 plus 2 is 5/3. The 1/3 plus 2 is 7/3. So we have it. Not yet. You can check end point, conversion or diversion. You can plug 5/3 into x. So we have negative 3 to the power n, 5 over 3 minus 2 to the n. So what's that? This is summation n equaled 0 to infinity. Negative 3 to the power n times 5/3 minus 2 is, sorry, 3 here. Negative 1/3 to the power n over square root of n plus 1. This is the same to summation n equaled 0 to infinity. You can combine this one. We have negative 3 times minus 1/3 to the power n. You can combine over square root of n plus 1. So negative 3 to the times minus 1/3 is only 1. So exactly summation n equal to 0 to infinity, 1 to power n over square root of n plus 1. 1 to power n is just 1 over square root of n plus 1. So what do you think? So this series is convergent or divergent? So what do you think? This series is convergent or divergent? The summation from n equal to 0 to infinity, 1 over the square root of n plus 1. The series is convergent or divergent? Divergent? Is it divergent? Yes, this is divergent. You can change it like this, exactly. P series divergent. The second case, x equals 7 over 3. You plug 7 over 3 into x. So here, and calculate. Summation n equaled 0 to infinity, negative 3 to the power n times. The 7 over 3 minus 2 is 1/3. 1/3 to the power n over square root of n plus 1. This is a summation n equal to 0 to infinity. You can combine negative 3 times 1/3 to the power n over square root of n plus 1. 3 is crossed out. We have summation n equal to 0 to infinity minus 1 to power n over square root of n plus 1. The series is, this series is convergent or divergent. What do you think? Convergent? Yeah. By using what kind of a test do you want to use? Yeah, thank you guys. Yeah, this is conversion by using alternating series test. So, what is radius of convergence? What's the radius of convergence? How can you decide radius of convergence? Do you remember? Here, this is interval of convergence here. So we have this one. Yeah, 1/3 is right. 5/3, 7/3. What's it like length? This length is 7/3 minus 5/3. So next divided by 2. This is same 2. 2/3 over 2. 2/3 times 1/2 cross out. Yeah, 1/3. This is idea for finding radius convergence. Another idea is, remember, absolute value of x minus a is less than r. This number is radius convergence. From here, 1/3 is exactly radius of convergence. You can use it either way. So 1/3. Interval of convergence is here. Series converges at 7/3. So only include right in the point. The series is divergent at x equal to 5/3. Don't include. Answer is half closed interval 5/3 and 7/3. This is like a whole idea for solving this kind of problem. Okay, the next one. So we are going to section 11.9. Was it like 11.9? The representation of a function as power series. So here, this is our line. How to represent certain types of functions as a sum of a power series. So we have some methods by geometric series, by differentiating a series. I can explain today. By integrating series, same. I will explain today the 3 methods. The first method, the Kasia will explain tomorrow by using Taylor series or Maclaurin series. Why do you express a known function as a sum of infinitely many terms for integrating functions that don't have elementary antiderivative? One example, we don't have it. The integral formula, integral 1 over 1 plus x of 7 dx, we don't know. How can you find this integral? You can change it 1 over 1 plus x to the 7 to power series. Next, take integral very easy. This is the idea. Second one, approximating function by a series. It's the same. These things explained by the Kasia tomorrow. The approximate E. How can you approximate E? Yeah, by using the power series. This is the idea. Third one, solving differential equation, the non-math 141. If you take math 251, math 250, you learn this kind of method. Okay, today, I'm going to focus on this one. Here, second one, third one, and this first one. You can focus on these 4 kind of things today. Geometric series. So like this. So how can do that? So we know this one. Summation n equal to 0 to infinity x to the n. Same to 1 plus x squared plus x cubed and so on. So like this. So what's that? This is geometric series. So was it like first term A? First term A is this one. Was a common ratio R like X. So when do you have a conversion result, the absolute value of X is less than 1, we have conversion result, right? In this case, conversion result. What's a conversion result? a over 1 minus r. So a equals 1. 1 minus r is x. 1 over 1 minus x. When do you have this conversion result? So absolute value of x is less than 1. We have in this domain, the power series equals 1 over 1 minus x. So we have to going backward. The 1 over 1 minus x is given. We can change it to the power series representation, n equal to 0 to infinity, x to the n. Expanded form is 1 plus x squared plus, and so on. So when do you have this result? Absolute value of x is less than 1. So this is idea. 1 over 1 minus x is given. You can change it to the power series representation. So we have it. This example, 1 over 4 plus x squared as the sum of power series and find the interval of convergence. So how can you find this one? So we use geometric series. So first one, you can change this 4 to 1. How can you change it for only factor of 4? So 4 times 1 plus x squared over 4. The next, you need negative sign. You can change plus x squared over 4 to the 1 minus x squared over 4. Is right? You can change this one to the minus negative x to the 4. So next, you have to plug this value into here. Is right? You have to keep 1 over 4, change the summation, n equal 0 to infinity. So you can plug minus x squared over 4 into this x and this x. So we have negative x squared over 4 to the power n. So like this. Right? The next one was like this one. This is the same to the minus 1 times x squared over 4 to the power n. You have to distribute power n to the minus 1 and x squared and 4. So same to the minus 1 to power n, x squared to the power n over 4 to the power n. You can split. So same to what? 1 over 4 summation n equal 0 to infinity minus 1 to power n x squared to the power n over 4 to the power n. So summation n equal to 0 to infinity minus 1 to power n change 2n x to the 2n over 4 is going to inside. What does it mean? This is same to 4 times 4 to the n. Same to 4 to the power n plus 1. You can change it 4 to the power n plus 1. We have this result. This is the whole idea for finding power series representation. So like this. The next tip. How can you find interval of convergence? The same. What's the log of minus x squared over 4? The log of common ratio. You can plug this log of common ratio into here and solve inequality. This is the idea. So you plug the common ratio into here, common ratio. So we have it. So same to the next one. Change positive times 4. 4 is crossed out. Absolute value of x squared equals 4. The next, take a square root. We have it. So x is between negative 2 and 2. That's it. What's the interval of convergence? This one is interval of convergence. This is the whole idea for solving this problem. The next one, differentiation of a power series. How can you take a derivative of power series, summation n equal to 0 to infinity, c to the n, x minus a to the power n prime? Here, I'm going to use expanded form. This inside one is exactly same to the c0 plus c1x minus a plus c2x minus a squared plus c3x minus a cube or something like that. So this is what? Exactly c0 prime plus c1 times x minus a prime plus c2 times x minus a square prime plus c3 x minus a cube prime and so on. So like this. What is c0 prime? What is c0 prime? c0 prime is, what is c0 prime? Do you know c0 prime? Zero? Is it right, zero? The c0 prime is zero? Is it right? Yes. c0 is constant. Constant prime is zero. Plus the c1 x minus a prime is keep constant c1. X minus a prime is just 1. You can keep c2. The x minus a square prime is the 2 times x minus a plus c3 x minus a cube prime is 3 times x minus a square and so on. So like this. So we have this one. The next you can change it. So this is the same to c1 times x minus a to the 0, 2 times c2 x minus a to the power 1, 3 times c3 x minus a square, 4 times c4 x minus a cube. I can change it back to summation form. Summation n equal to 1 to infinity n times cn x minus a to the power n minus 1. You can change it like this. So we have one result. Was it like a derivative of summation from n equal to 0 to infinity c sub 2n x minus a to the power n? So take a derivative inside one is right. You can take out summation, take out summation. Next, only x minus a to the n prime. Exactly n times x minus a to the n minus 1. One important thing. N equal to 0, change it to n equal to 1. Why? Here. What is c0 prime? c0 prime is 0. This is the reason. The 0th term is gone. Always change it, n equal to 1 to infinity. The integration of power series. Here, how can you find this one? Use substitution. U equals x minus a, find du, x minus a prime dx is 1 times dx. The next change. Integral x minus a is like u. You can plug u into here. dx is du. So we have here and here. The next integral c0 plus c1u plus c2u square plus c3u cube and so on. You can find entire derivative. Here, the integral c0 is c0u. Integral c1u is c1u square over 2. The integral c2u square is c2u cube over 3. The integral c3 over u cube is c3 u to the 4 over 4 plus and so on. This is like an indefinite integral. We need constant c. You can change it back to summation form. C plus summation n equal to 0 to infinity cn u to the n plus 1 over n plus 1. The last one, you change back. So u equals x minus a, you plug into u, so we have this result. So what happens? Only take out summation. Find integral of x minus a to the power n is like power rule. X minus a to the power n plus 1 over n plus 1. This is like idea. I'm going to summarize. theorem. If the power series summation Cn x minus a to the power n has a radius of convergence r greater than 0, then the function f defined by like this, the also differentiable interval a minus 1 a plus r, what is f prime of x, summation n equal to 1 to infinity n times Cn x minus a to the n minus 1. What is integral f of x dx? C plus summation from n equal to 0 to infinity Cn x minus a to the power n plus 1 over n plus 1. So how can you memorize this one is better? Like this. I can show to you. What's that? This one is memorized like this. Summation n equal to 0 to infinity C n x minus a to the power n prime. I can do that. You have to keep summation. You can keep constant Cn. Only find x minus a to the n prime. You can use power rule and chain rule, like n is down, x minus a to the power n minus 1. But next, you can change index because the zeroth term C0 prime is 0. This is the reason. Zeroth term is gone, n equal to 1 to infinity. So how can you find the integral? This is similar. The integral summation n equal to 0 to infinity Cn x minus a to the power n dx. How can you find the integral? First one, you have to take out summation and constant Cn. The take out summation and constant Cn, just integral x minus a to the power n dx. What's the like answer? You can keep summation n equal to 0 to infinity Cn, find antiderivative by using power rule. 1 over n plus 1 x minus a to the power n plus 1. This is indefinite integral. You need to write C. This is two forms like this. This is the idea for memorizing these two rules. So this is one important thing. What's like a radii of convergence of the power series of derivative, power series of integral? Always R. So here, the original one has radius convergence is R. What is derivative and integral? Doesn't change. It always R. So what does it mean? So you don't need to find R again. So exactly same to the original one. This is like idea. This is one example. How can you find 1 over 1 minus x squared? It's a power series representation. How can you find 1 over 1 minus x squared? How can you find? Do you have any idea for finding power series over 1 over 1 minus x squared? How can you find? Was it like a GS? Geometric series? Oh yeah, and one more. The geometric series and differentiation. This is the idea here. We can use geometric series 1 over 1 minus x. 1 over 1 minus x is summation from n equal to 0 to infinity x to the power n. What's the next step? Differentiate each side of the equation. So how can do that? Here. Take derivative. So like this. What is 1 over 1 minus x prime? You have to use quotient rule. 1 prime times 1 minus x minus 1 times 1 minus x prime over 1 minus x square. What's 1 prime? 0. The next one is minus 1 times 1 minus x prime is minus 1 over 1 minus x square. The minus 1 times minus 1 is 1 over 1 minus x squared. Exactly left hand side. What's it like right hand side? The right hand side is, you have to use formula. Summation, what's x to n prime? So n times x to the n minus 1. What's it like a starting index? What's that? N equals, what's that? 0. What is it like a starting index? N. What's starting index? N. Do you know the starting index N? Is 1? Yes. Here, what happens? What's 1 prime? 0 plus x prime is 1 plus 2x plus 3x squared, something like that. What does it mean? Zeroth term is 0, is gone. N equals 1 to infinity. So like this. What's the conclusion? The left-hand side is 1 over 1 minus x squared is exactly left-hand side. So 1 over 1 minus x, the square is summation n equal 1 to infinity n times x to the n minus 1. That's it. You can use geometric series and differentiation. You can find this answer. This is the whole idea for this power. For this power. 2. The radius convergence is 1. Do you remember the previous one? The here. So was it like here, derivative 1? Was it like a radius of convergence of derivative 1? The r, exactly same to original radius of convergence. So here, was it like a radius convergence? The original one has 1. This is radius convergence. Was it like a derivative 1? The derivative 1 doesn't change, the 1. So you don't need to find radius of convergence by using ratio test. You don't need. So don't waste your time. Just exactly same to original one. Was it like this one? That's simple. Only multiply the both sides of second equation by x cubed, the next one. X cubed times 1 over 1 minus x squared equals x cubed times summation from n equal to 1 to infinity n times x to the n minus 1. So left-hand side is x cubed over 1 minus x squared. What is one? X cubed is going to inside combine. X cubed times x to the n minus 1 is x to the 3 plus n minus 1, x to the n plus 2. So we have it like this. What is radius of convergence? What's the radius convergence of this one? What's the radius convergence of x cubed over 1 minus x squared? Do you know what is the radius of convergence? The radius of convergence is, do you know radius of convergence? Yes, doesn't change. Always same to original one. Yeah, original one. This is the idea. So second one, find a power series representation for ln of 1 plus x and its radius of convergence. How can you find? This is the idea. Use geometric series. So first, you can change this one to the 1 over 1 minus x form. How can you do that? Take derivative. ln of 1 plus x prime is 1 plus x prime over 1 plus x. The 1 plus x prime is just 1 over 1 plus x. You can change 1 over 1 plus x to this form, the positive x to the negative x. You can change it. So next, you plug minus x into this x, plug into x here. Same to summation n equal to 0 to infinity minus x to the power n. This is same to summation n equal to 0 to infinity the minus 1 times x to the power n. You can distribute n2 minus 1 and x. This is a summation from n equal 0 to infinity minus 1 to power n x to the power n. This is like idea. So like this. So how can change back? And then 1 plus x. The next step is take what? integral. Take integral. Take integral. This is idea. So one more. So radius convergence is 1. That doesn't change it. So next, take integral. Like this. Take integral here and here. So what happens? Like this. Integral derivative gone, and then 1 plus x. Next, as I said before, take out summation and coefficient. Take out, so we have it. So integral x to the n dx is 1 over n plus 1, x to the n plus 1. So like this. It's good? The next, how can you find c? You can plug x equals 0 into here, find c. This is the idea. So from here, you plug x equal to 0 into here. So adding up 1 plus 0 equals c plus summation n equal to 0 to infinity minus 1 to n, 0 to n plus 1 over n plus 1. 0 to n plus 1 is 0. 0 over n plus 1 is 0. Minus 1 to power n times 0 is 0. The summation of 0 is the 0. So what happens? This is same to adding up 1 equal c plus 0. What is adding up 1? What's adding up 1? Yep, this is 0. So we have 0 equal to c. 0 equal to c. So we have 0 equal to c. You plug 0 equal to c into second equation here. Plug 0. So we have adding up 1 plus x is summation n equal to 0 to infinity minus 1 to n x to the n plus 1 over n plus 1. So another one is you can change initial index 0 to 1. You can reduce power by 1. Minus 1 to n minus 1 x to the n over n. This is like idea. It's good. This is the whole idea. So I'm going to try to solve one more problem. Do you know how can you find power series of the ln 1 plus 2 plus x square? How can you find the power series of ln over 2 plus x square? I want to use formula. You have to memorize. This formula is very useful. Adding up 1 plus x is summation n equal to 1 to infinity minus 1 to power n minus 1 times x to the n over n. So how can you do that? You can factor out 2. Adding up 2 times 1 plus x square of 2. You can split. Adding up 2 plus adding up 1 plus x square of 2. You can keep adding up 2. The next two. This one is same to here. So what's it like x square of 2? The load of x. You plug x square of 2 into this x. So we have summation n equal 1 to infinity minus 1 to n minus 1 times x square of 2 to the power n over n. And simplify. Adding up 2 plus. summation n equaled 1 to infinity minus 1 to power n minus 1 times. You can distribute power n to numerator x squared, denominator 2. We have x to the 2n over 2 to the power n over n. So simplify more. The ln of 2 plus summation n equaled 1 to infinity minus 1 to power n minus 1 times x to the 2n over 2 to the power n times 1 over n. So final answer is ln of 2 plus summation n equaled 1 to infinity minus 1 to power n minus 1 times x to the 2n over n times 2 to the power n. This is the whole idea. So one more. What is radius of convergence of ln of 2 plus x squared? What is radius of convergence of ln of 2 plus x squared? Do you have any idea? Do you know what's the radius of convergence of ln of 2 plus x squared? Do you know? Do you know? The idea is like this. Was it like original one? ln of 1 plus x. So here, what is log of x squared of 2? This is log of x. Was it like radius convergence original one? R equals 1. What does it mean? Absolute value of x is less than 1. Just exact meaning. So you plug x squared of 2 into x. You can calculate here. Absolute value of x squared of 2 is less than 1. You multiply the both sides by 2. Absolute value of x squared is less than 2. You can take a square root. Absolute value of x is less than square root of 2. The answer is square root of 2. This is the whole idea for finding radius of convergence. This is one application of ln function, a power series form. The next tip. Final power series representation of inverse tangent of x and its radius of convergence. How can you find? We can use similar idea for finding ln of 1 plus x. Here, 1 over 1 minus x is summation n equal to 0 to infinity x to the n. What's the radius convergence? Here, this one is the radius of convergence 1 is original one. You can take a derivative. Inverse tan x prime. Do you know what is inverse tan x prime? What's inverse tan x prime? Do you know? What is inverse tan x prime? Inverse tan x prime is, do you know? What is the answer? Inverse tan x prime is 1 over 1 minus x is right. What do you think? 1 over 1 minus x? So what is the answer? What's inverse tangent of x prime? Inverse tangent of x prime is here. 1 over 1 plus x squared. So next, you can change it. So this is a negative x squared to the minus x squared because we can change it 1 minus x form. So next, you plug negative x squared into x. Here, this is same to summation n equaled 0 to infinity minus x squared to the power n. So distribute n to the minus 1 n squared. Summation n equaled 0 to infinity minus 1 to power n x squared to the power n. So same to summation n equal to 0 to infinity minus 1 to power n x to the power 2n. So we have it. So like this. Was it like a radius convergence? the same things. You can plug minus x squared into common ratio x and solve. You're right, Cam is right. The minus x squared is less than 1. The only eliminate negative sign. The next one, take a square root. Absolute value of x is less than 1. The radius convergence is 1. So we can use the same things. Take integral the both sides here. Take integral and take integral. So like this. We have it. So we have this result. Integral and derivative gone, inverse tangent x. Here, take out summation and constant. The summation from n equal to 0 to infinity, minus 1 to power n, integral x to the 2n. Find antiderivative. Integral x to 2n is exactly x to 2n plus 1 over 2n plus 1. This is indefinite integral with right c. So radius convergence is doesn't change 1. Right? Doesn't change 1. So far we have it. How can this side see similar? You substitute x equal to 0 into second equation. The inverse tangent of 0 equals c plus summation n equal to 0 to infinity minus 1 to n, 0 to the 2n plus 1. The 0 to 2n plus 1 is 0. This is also 0 minus 1 to the n times 0 is 0. Summation of 0 is, the summation of 0 is also 0. So what happens? Inverse tangent of 0 is just c. What's the inverse tangent of 0? What's the inverse tangent of 0? Yeah, this is 0. So we have 0 equal to c. You plug 0 into here, this is gone. The inverse tangent of x is exactly summation. So we have it. It's good. This is whole idea. The similar. Was it like application of this one? The same. You have to memorize this rule, very useful. The one application is here. Inverse tangent of 5x. How can you calculate? You plug 5x into this x. We have summation n equal to 0 to infinity minus 1 to power n, 5x to the power 2n plus 1 over 2n plus 1. The next summation n equal to 0 to infinity minus 1 to power n, distribute power 2n plus 1 to number 5 and x. So we have 5 to the 2n plus 1 times x to the 2n plus 1 over 2n plus 1. That's it. This is the answer. So one more. How can you find radius of convergence r? So similar. You plug is a 5x, the root of common ratio of 5x into here. What does it mean there r equals 1 from the inverse tangent of x? Exact meaning is the absolute value of x is less than 1. So you plug the 5x into here. So we solve 5x. Absolute value of 5x is less than 1. We have to solve this inequality for absolute value of x. The next divided by 5. The absolute value of x is less than 105. So what is it like a radius convergence? Radius convergence is the 105. Just like a whole idea for solving this problem and application. Next one. The evaluate integral x squared over 1 plus x to the 7 as power series. How can you do that? You can use geometric series. X squared over 1 plus x to the 7. You can change it. X squared times 1 over 1 minus negative x to the 7. The same. You can keep x squared, this one, and plug minus x to 7 into x. here, times summation n equal 0 to infinity negative x to the power 7 to the power n. Same to x squared times summation n equal 0 to infinity. You can distribute n to the -1, x to the 7. So we have negative 1 to the power n, x to the 7 times n. So next to combine x squared, x to the 7n. You can combine these two things. So what happens? This is same to summation n equal 0 to infinity. -1 to power n times x squared times x to the 7n is x to the 7n plus 2. We have it. So next, you need to find radius of convergence. How can you do that? You plug common ratio negative x to the 7 into here and solve. It's the same to only like this. You can take power 1 over 7, power 1 over 7. We have absolute value of x is less than 1. So radius convergence is 1, doesn't change it. Right? This is like first one. This is not a final. What's the next step? So far, so we have like this. So we have it. The next, you have to integrate both sides of the equation. So next step is what? Take integral. It's like a main problem. Take integral. So like this. So we have here. Next, calculate. Take out summation and -1 to power n integral x to the 7n plus 2 dx. So you have to keep summation n equal to 0 to infinity -1 to power n. Find integral x to the 7n plus 2 by using power rule. 1 over 7n plus 2 plus 1 x to the 7n plus 2 plus 1. This is indefinite integral. You need to write constant c. So we have c plus summation n equal 0 to infinity -1 to power n. X to the 7n plus 2 plus 1 is x to the 7n plus 3 over bottom one is 7n plus 3. So we have it. What's the radius convergence? Exactly same to original one, like r equal to 1. Okay, so this is exactly the order of today's lecture. Do you have any question? Today's lecture, if we have any question, you can write in chatting board. I will explain more details about your question. So do you have any question? If you don't have any question, so you can leave. This is like June. And any question? Sure. I'll update the video and then yeah, sure. I update this video. One more. I update some of my lecture note on Canvas in the 20 minutes later, 10 minutes later, I think. Yep. You're right. What is the meaning of the radius? Like this. In this problem, the radius is exactly 1. What does it mean? X is only this domain. This integral is exactly same to power series, but absolute value of x is like greater than 1, not in the domain. This integral x squared over 1 plus x to 7 dx is not equal to power series. This is the exact meaning. We need, this meaning is radius of convergence. Does it make sense? Oh yeah, interval and then radius convergence is the, what's like a difference here? From here, this is convergence or divergence. So how can you know that? So interval of convergence is like you have to check end point. So from here, exactly between this one and this one. So this is like radius convergence is exactly only this number. If you don't find interval of convergence, you have to check. So this series is convergent or divergent at x equals to -1, x equals to 1. Is right? You can check. So in this case, x equals, I think, the -1 or 1, convergent or divergent. It's like different. Sometimes the -1 is included, sometimes 1 is included. The 2 endpoints are excluded. Sometimes 2 endpoints included. This is only difference between interval and radius convergence. The endpoint included 1. This is only different things. Does it make sense? Okay. So if we have more question,